Assalamualaikum and hi to everyone. Thank you for watching my video. So in this video, we continue on chapter 5 part 2. Okay, in the previous video, we already learned about the non-preemptive and preemptive scheduling. Okay, you already being introduced with several algorithms such as round robin, SJF, first come first serve, and so on. So in this video, we continue on another part of the CPU scheduling. Okay, we will talk about the multiple processor scheduling and the real-time CPU scheduling, and we go through for several exercises. So we'll go for the multi-level queue. Okay, multi-level queue, fine. A ready queue is partitioned into separate queues. We have the foreground and we have the background. So foreground for the interactive queue, and for background is we call as the batch. So process permanently in a given queue means process will be in a queue. So each queue has its own scheduling algorithm. Okay, for foreground scheduling algorithm, we use the round robin, and for background algorithm, we use for first come first serve, as we already learned those algorithm in the previous video. So scheduling must be done between the queues. Okay, first fixed priority scheduling means serve all from the foreground, then from background. Foreground first, then background. So possibility of starvation can be exist at this part. Okay. And then time slice, each queue gets a certain amount of CPU time, which is can schedule among its processes. So example, 80% for to the foreground in round robin and 28% for the background in the first come first serve algorithm. So multi-level queue scheduling, we have the highest priority and we have the lowest priority. For the lowest priority is based on student processes, and then after that is batch processes, and then we have the interactive editing processes, interactive processes, and system processes. So these are the priority in the scheduling part. So a process can move between the various queues. Okay, we may have various type of queues. So aging can be implemented in this way. So multi-level feedback queue scheduler defined by the following parameters. So these parameters will define about the multi-level feedback queue scheduler. Okay, first is based on number of queues. How many queues that we have. Scheduling algorithm for each queues. Okay, each queue may have different scheduling algorithm. Third, the method used to determine when to upgrade the process. Number 4, method used to determine when to demote the process. And then number 5, method used to determine which queue a process will enter when the process needs service. Which one that we can start the process. So example of the multi-level feedback queue. Okay, we have example here, 3 queues, Q0, Q1, and Q2. Q0 round robin with time quantum 8 millisecond. Q1 round robin with time quantum 16 millisecond. And Q2 first come first serve algorithm. So we have 3 type of queues, and each of the queues have different algorithm. Okay, for the scheduling, a new job enters the queue 0, which is serve FCFS. So when it's gain the CPU, job receive at millisecond. If it does not finish in 8 milliseconds, job is moved to Q1. Okay, at Q1, job is again serve FC fs and receive 16 additional millisecond. So if it still does not complete, it is preemptive and move to the queue number 2. Okay. So queue 0 with 8. If not finished, start with another queue. And if still does not complete, it will preempted and move to queue number 2. So Q0, Q1, and Q2. So next is about the multiple processor. Just now we talked about the multi-level queues. Okay, multiple processor scheduling. Okay, CPU scheduling more complex when multiple CPU are available. Okay, it's just similar like the thread. When we talk about single thread, it's quiet, straightforward. When we talk about the multiple thread, so it's more complex. So the same goes to the processor scheduling. So we have homogeneous processes within a multiprocessor. Okay, and then we have asymmetric multiprocessing. So this asymmetric processing, you can remember that we have the synchronous, asynchronous, okay, quite similar. So only one processor access the system data structure and alleviating the needs for the data sharing. For symmetric multiprocessing, each processor is self-scheduling. So each processor will do self-scheduling and all processes in a common ready queue. So instead ready, each has its own private queue of ready processes. So the difference between the asymmetric processing and symmetric processing. And then we have the processor affinity. So this one, affinity processor means process have affinity for the processor on which is currently running, either soft or hard, and variation including the processor's set. So in if the symmetric multiprocessor, okay, in SMP need to keep all the CPUs loaded for efficiency. How to keep all the CPU balance? Here we can use the load balancing, or push migration and pull migration. So load balancings attempt to keep workload evenly distributed. Mean we try to balance the workload to multiple processor that we have. And then we have the push migration. So periodic task check loads on each processor. So we'll check the workload on each processor. And if we've found push task from the overloaded CPU to another, means that if we found the overload, then we push it from one CPU to another CPU. And then for full pull migration, the either processors pull waiting task from busy processor, just tarik daripada processor yang busy. Okay. So now we have another term, multi-core processor. So the recent trend to place multiple processor core on the same physical chips, like our computer system nowadays. So this one is faster and can consume less power compared to the previous one. Multiple thread per core also, growing number of thread also increase, or we add more threads in the core. So this take advantage of the memory stall to make progress on another thread while the memory retrieve happen. So this one is multi-threaded, multi-core system. We have thread, we have computer cycle, and we have memory stall. So if we use the core, okay, if you wish we use the multi-core, then means we have multiple thread, we can add numbers or increase the numbers of thread in multiple core. So instead of a single core, so if we have multiple, then we can have many number of thread. So basically, under CPU scheduling, you already learned about the preemptive and non-preemptive scheduling. You should know the difference and the algorithms for both categories. And then for the scheduling criteria, we have the maximize. For maximize means we want to utilize the CPU that we have, the throughput of our CPU. And for minimize, we want to minimize the turnaround time, the waiting time, and the response time, so that make our process more efficient. Means we can have a better performance if we're able to minimize the turnaround time, the waiting time, and the response time. How to minimize? By utilize the throughput. For that, so these are the differentiate and the comparison between the preemptive and non-preemptive scheduling. So look at the preemptive scheduling first. Okay, in preemptive scheduling, the process are allocated for a short period. In non-preemptive scheduling, the process is allocated to the CPU and the resource will hold the process until it's complete its executions or change its state to waiting for the state from ready state, means for a switch part. So if you meet with the question that asks about the comparison or differentiate, you must make sure that you put in the right way. Means if we talk about the how the process, how the scheduling part allocated, so we go for the process are allocated. For this part, the item, the keyword is allocated, the process. So this one for a short period, this one already in the CPU and we need to hold. Okay. The second part, in the preemptive scheduling, we can interrupt the process in between of the execution. While in non-preemptive scheduling, we cannot do the interruption. Okay, we need to wait until the process completes. Then we can go for another process. In preemptive scheduling, has overheats of scheduling the process. In preemptive scheduling, there is no overheats. Okay, in preemptive scheduling, there is a cost associated with the preemptive scheduling. In the non-preemptive scheduling, there is no cost associated with the scheduling part. And in preemptive scheduling, if the process has the high priority arrive in the ready queue, then the process which has low priority may stop. In non-preemptive scheduling, if the process which has long burst time is executing, then the other method which has less burst time may stop. So that's the difference between the preemptive and non-preemptive scheduling. So that we go for the exercises. So please do exercises on question 1, question 2, question 3, question 4. Okay, and then we will discuss on the next class. So that's all for chapter 5. Thank you and assalamu alaikum.